Good morning, everyone. Anchoring of a cantilevered roof truss, real-time modeling. This is the topic of the session that I wanted to talk about. My name is Lucas, and I work as a computation evaluation engineer slash product engineer in the company IDEA StatiCa. So I'm mostly focusing on the concrete and the steel design, partial and verification processes. And my background combines civil engineering and applied mechanics with a focus on the connection design and concrete design. The content will be quite straightforward, real-time modeling of the roof truss or roof cantilevered truss. I would like to point it out some tips and tricks for this type of the connections and how to treat with those connections if you wanted to insert some reinforcement and do the, you know, reinforcement concrete code check according to the Eurocode, and also the steel part will be code checked according to the Eurocode provision. So we'll start off with global model where the boundary conditions will be assigned as a standard pins, no rigidity, no stiffness. I just applied one force that is applied at the end of the truss that is representing some beam and some concentrated load. Actually, this is the truss model, so only axial forces will be transmitted. Later on, we will do a second step where we will focus on the removing of the nodes and merging and coupling of the members into the selected nodes. Some utilizing of predefined templates to make it quick and leave up more space for discussion about the results and the behavior of the connection. And 3D detail as a tool for reinforced concrete design, mostly the discontinuity region design, focusing on the anchoring, because actually those anchors are cast in place with some washer plates. So all the procedure will be discussed and debate here. So consultation and the training. So I've been endorsed as a certified trainer. So if you have some project or some you want to be trained in the IDEA StatiCa, so please do not hesitate and drop the message into the struckinsight@gmail.com. I will respond to you soon. And for the following communication, and if you like the session, so do not hesitate and subscribe this channel, and you can also follow me on the socials where I'm just trying to promote some tips and tricks, some verifications and the validations, what we are doing in the IDEA StatiCa, steel connection design, concrete connection design, anchoring, also some pre-tensioning, post-tensioning, everything what is related to IDEA StatiCa products. So feel free and follow me on the socials. So actually, thank you for your attention. This is not the end. This is just the beginning where we will jump in to the application. So for the demonstration, I just used the IDEA StatiCa, or sorry, the Midas Civil. The Midas Civil is the tool for global FEA design. This is mostly for bridge engineering, but this procedure is versatile, so you can leverage every FEA software you have. Of course, you need to the software need to have a support from the sense of the BIM link. So actually, this is my truss structure. As you can see, that's made of made from the truss structures or truss elements. The elements are basically constrained at the end. So you can observe that here are some in the property boundary, just something like that. What is more familiar to structure engineer, that all translations are restrained. So those are like a fixed pins, and it brings you like a clear load path from the sense of the axial forces. So once I display the load is like a load case that will be after the simulation in the post-processing, because we are considering linear elastic analysis with a linear elastic constructive law for this truss elements, small strains, small deformations. So those are the assumptions that I am stepping in. And in the first stage, I need to calculate the model. So once I calculate the model, so I'm actually in the post-processing, and in the post-processing, I can just work with the results. So at first, if you if I will just go to the here are the results, and in the results, I will just select the beam forces. In the B forces, I will select the Fx. What is the normal force? So actually, here is the combination. So what I can see, this tensile force 168. Here's the compression force in the diagonal and compression force or compressive force in the bottom chord. So actually, if I want to export it, and I want to see also how I create the combination, or how the combination has been created, I can just utilize this pop window at this position where the load effect has been multiplied by the factor 1.35. That is represent some permanent load. Just one load case to show you how it works and make it quite quick. Actually, if you wanna run if you wanna run the app, you need to at first run the API. So if you run the API, so you can just move forward to the activation of the API plugin. Based on that, I will select the project. This is what I can close. As you can see, there is something is running behind, so it means that interface checkbot has been initiated and is running. So actually, I will select all of the members because my goal is to scan all of the structure, all the members, and import all necessary informations to checkbot. Okay, you can see that I'm just selecting the steel. Design code is Eurocode, and I will create a project. If you hit the button connection, so all of the connections will be imported here, and you can observe the scanned structure with all internal forces combinations. So actually, in the meantime, I can just show you that in the folder, has been created the checkbot file, where in the checkbot file are all the necessary information that you need to know. And you can also take advantage that, for example, connections that will be created by you in the checkbot can be opened up here. Also, you can just observe some XML file. There are all the necessary informations about the nodes, about the coordinates, points, basically all the informations that's providing the input for geometry and internal forces development in the checkbot. But as you can see, I'm just experiencing right now that my section has been rotated. It can happen, but that's, you can just very swiftly reverse it. And in the conversion table, there can happen sometimes that the section is not recognized, and it's coming into the checkbot as a section that is unassigned. If it's unassigned, this conversion table will appear and give you the option to select the section from the library. So this is the standard library that we support: rolled, welded, composed, or cold formed sections. And in the part of the welded composed sections can be also used some general steel section that enabling to merge more members or cross sections together, or impose some DXF reference. So actually, for our case, it's not necessary, but if you wanted to design the connection or the anchoring of the left part, there is a top chord, diagonal, and bottom chord to concrete column. So you can observe like two nodes that's are visible in the 3D scene, but IDEA StatiCa mostly work during the import just with the one node. So if you wanted to merge the top chord to the node that is aligned with the bottom chord and the diagonal, so at first you need to click on the node it's highlighted, and you are able to explode the group. At first you need to explode it and take it out from the group, otherwise you're not able to delete it. Once you delete it, the bubble representation of the node will disappear, and if you click on the section in the bottom, you are able to assign more members. And actually, once you click again to the node, you're able to see that all members that have some name addressing the name are as a connected member. So it means the software understand that all members will be exported in the one step. So I can just move forward, and yes, so I have just received the members, and the node that has been imported is disclosed here. So it means that all the forces are basically related to this member. So once you click on the load effect, you can observe what will be basically the reactions or the forces, the unbalanced forces in the nodes. And how to understand those forces. So at first, those forces are related to global coordinate systems, and the forces that are embedded here in the step in the property grid, the forces are related to local coordinate system. So that's very essential. Those are differences, variations that you need to keep in mind if you wanted to, for example, balance the forces once you don't have the unbalanced forces. But it's not recommended to do it by hand. You should receive all the time from your FEA software the balanced forces. If you have, if the connections are if the connections are out of the support and are not basically in the area of the anchoring, because where is the support, you will always experience the unbalanced forces. So actually, once I wanted to get this value, I will just take a snapshot and show you how it works. Okay, so in the first glance, here is some force that is going in this direction. So once I decompose the resultant force into two vectors of the forces, so this F set is equal to minus 33.7 because the angle is 38 degrees. So once you multiply those force times sinus 38 degree, you will receive the set forces. And how the bending moment has been developed, as you can see that here is the y coordinate system, like a global, and it's the rotation is around. So actually you can observe that this force is causing the bending moment. The lever arm here, like the eccentricity, is 0.80 meters. So once you want to calculate the bending moment, you will take the force times the eccentricity and you will obtain this 135 kilonewton meter. So this is basically the essence, how the structure are counted and how the mostly unbalanced forces are counted. So actually, when you have it, you can just move forward, and I will utilize the connection library where this connection has been created. So if you are just watching this video, what you are able to do, you are able to download the projects from the folder, from the article. In general, the article is here. It's called Truss Anchoring Tips and Tricks. So once you get it in, you will just scroll down, and here are the files as a checkbot, IDEA StatiCa Connection and IDEA StatiCa 3D detail. Okay, so once we have it, you can see that all the informations and all the properties has been assigned accordingly. The installation process for the anchors is cast in place. These are some washer plates. The washer plates has at the end some washer that transferring all the forces from this surface to the proximity of the concrete. And the type of the anchor is M20 with a strength 10.9. The concrete is from C20/25, so that's been defined. As you can see, the plates are coming from the S275, and the member are from the steel S235. Okay. So once you have it, we can just proceed to the calculation to see if my model is stable. So once you are trying to analyze the connection and the 1 bolt operation or operation with 1 bolt is exhibited on the structure, so you will receive something like this, that the calculation cannot be proceeded completely, and the problem, if you go to the check, is missing basically here. Yeah, so you don't know what to do, and what happened, and the reason is the instability in the area of the bolt, because the part of this diagonal is starting to rotate as a flexible body, and it initiates to, he cannot find the equilibrium because there is some motion, and the stiffness matrix is ill-issued. Yeah, so this is basically the problem that from the point of view of the instabilities. Once you know what is basically happening, I can just go to the design, click on the member, and I need to change the model type and or to the normal force and the shear force in 2 directions. Those are the forces that are transferable. Into the members. So once you do it like that, the rotations, or rotational degrees of freedom, are restrained. So actually, let me take the screenshot. So once I have it, so what happened if you use the model type that is called, I will call it model type, that is called n VYVZ. What does it mean? So it means, from the point of view of the constraints, so constraints at the end of the condensed element. So condensed element, basically you can imagine as some element that has some like a specific length, that where the L is, I believe that it's 4 times the height of the section, and at the end of the element is the node, and to the node is applied the boundary condition where all rotations has some prescribed rotation that is equal to 0. So the connection is able to move in these directions, but he's not able to rotate. And once you do it, you are basically preventing this flexible body rotation. And if you do it, your structure at this area is stable. Once you have like a 2 bolts, if you just neglect or not utilize this constraint, the calculation will be running. But there is a problem that if you omit this constraint at the end, your member will deflect like that. If you omit this boundary condition. If you do not omit the boundary condition, and you will utilize the boundary condition that is closer to the reality, what will basically happen? So actually there will happen something like that. So you have the boundary condition here. And if you just draw the rest of the truss element, so it will just drop down in this direction. Yeah, so it will just drop like that. So at this point, it's like a influx point. There is like a zero rotation, or where is the curvature is changing. So that's more closer to reality, utilize those constraints than to leave it like that, because without these constraints it will deflect in at this position. And I forgot to mention that the force is acting. This force. This force is basically acting in the centroid of the section, or center of the gravity, but the bolts has some eccentricity. So it means you are receiving some, I would say, secondary moment that is called by this force time this eccentricity, and it leads to non-conformities that will give you the hint that the sum of the rotations, or the reactions due to preventing the rotations, Rx or Ry or Rz, it depends where the eccentricity is associated from the point of view of the global coordinate system. So this is related to global coordinate system. There is like a sum of the rotations, or some of the reactions, that gives you some information that once I calculate it, as you can see, there is some problem with the detailing of the welds. Fine, I can just double check what is happening, but if I will go to check, so in the analysis, as you can see, there is written that Ry is 5.5 kilonewton meter. So it means the boundary conditions at the end of the elements, the members, are causing in some the additional reactions 5.5 kilonewton meter. So actually right now we can just move forward and see what is happening with the detailing. So let's go to the welds. I can just stretch the window here. And if I maximize the window, so in the bottom, there should be written that stronger weld material is selected than the weakest connected parent metal. Weld ultimate strength should be lesser or equal to 390 megapascal. So actually we can just double check what material properties has been assigned. So I will just use automatic. Here also automatic. I will just calculate it again. So as you can see, the warning has been disappeared because he automatically taken over the properties of the related related gusset plate or the base plate. So actually, right now there is a problem with the anchors where it's shining out the red cross, but the utilization is on the 38%. So we can just double check what is happening. If you click on the anchor and you will go to the report or to the check. So in the anchors, I'm just observing that detailing is fine, but the status is announcing me some red cross. So actually, if you double check what the report give me as a hint, so according to the code, the groups at separate base plates interact with each other in one concrete block. So this is out of the scope of standard anchoring design. Concrete breakout intention and concrete pry-out are not checked. Concrete edge filler is also not checked. So 3 code checks that are quite important for code checking of the concrete block are dismissed because the code is short on that. Because there is like a multiple anchors that are connected into the prefabricated concrete column, and at this point, if you know that this concrete block is represented by the Winkler springs that are just working as a compression only elements, because all the actions in the tension is taken by the anchors, and also the interaction in between this area and this area is completely disregarded. So that's also quite problematic because you want to investigate what is happening and in between the connections, because the connections are very close to each other and there will be some flow of the stresses that will be affecting each other because they are not sufficiently far away from each other to analyze it separately. So there is an option what I can do, and I will convert all of the data on the one click using this RC check. But before I just step in and analyze the structure, I just forgot to mention that me personally, I'm just refining the mesh. Yeah, so actually at this point, I will just go to the model and the number of elements on the biggest members, web or flange, put there 24. Number of elements on the individual plates is 40. 2 mm is minimal size of the element in general, and the maximum size of the element is 25. So once I will do it, I will just analyze the connection again, and we can see how the mesh has been refined. Yeah, so we can move to equivalent stress, mesh deformed shape. And click to maximize the view. So actually right now you can see that the mesh is or has been refined. So once the bolts or the bolts are assigned, the openings are automatically created, and you will receive also the outer ring that is representing the washer and the nut, where all the constraints are properly assigned, and that are representing the punching due to the washer and the nut, or how the washer and the nut are like realistically represented. Here are used some constraints, rigid body equations that's are working accordingly. Okay, so I can see that the bolt forces, here is a tension because here is a tensile force. All the arrows are shining red because of the problem with the code. So that's like information for structural engineers to be aware that something inappropriate is in the code check. And once I would like to see what is happening in the concrete block or in the stress in the area where the bottom chord and the diagonal are pressing into the concrete, so it behaves like that. Here is some localized area where has been increased some stress in the compression because the gusset plate is like pushing the forces or the pressure over the welds or through the thickness of the plate. So there is maximal utilization or the stress 14.3 megapascal, and actually right now I can move the structure to the 3D detail. So once I utilize the RC check, I will just save it as a 3D detail, and once I do it, I will receive all of the informations. Okay, so once the concrete block with the base plates and the other entities is imported, so it's very important to assign properly the surface supports. So the surface support is automatically assigned to some random surface, but I know that this is like a part of the column or submodel of the existing prefabricated column. So the first support will be related to surface number 4. And how it works. So in general, because we are on the level of the solid elements, so the surface support can remove 3 degrees of freedom. Just the translation. X, Y, and the Z. So once the button is going to be is getting to be great, so it means that the support is compression only. So actually at this point, I don't need that to have it like a compression only. And I will just copy the operation and assign it to surface number 2. But at this point, the direction of the supports is related to local coordinate system, where you can see that the Z direction is here. So I can just remove the Z direction and the column is restrained at this part in the Y and the X direction. So actually, you are not able to calculate the model because the software warns you that the structure is not reinforced, and we are not able to calculate the plain concrete at all. So this is very, very important to understand that all your models that will be prepared here need to be properly reinforced, not only by the main reinforcement, but also the I would say reinforcement that is necessary for detailing. All the reinforcements are accounted at this model because that's based, the loads will be transferring through the like a medium of the concrete to reinforcement 3 bars, and all the reinforcement 3 bars have some level of the stiffness, some portion of the rigidity. So it means that's very essential and very important to consider all the reinforcement inside a concrete block. Okay, so once we double check the anchors, you can just click one by one. So the anchors are taken over the information from the connection app. So the installation process, cast in place, washer place, the diameter. Of course, you are able to change it here. If if the connection will not be passing, you can change it, but you need to again recalculate it in the connection app. But here is the very important part: the interconnection with the base plate. So actually, at this point, once the import is activated, so the activation of axial force transfer has to be disabled, and activation for shear force has to be enabled. So that's very important. Why? Because once you double check, if you import it, the loads in the axial direction already exists, and if you turn it on, so you will just receive some forces that doesn't make sense. Yeah, it will behave completely weird, and because basically the anchor will be connected with a base plate. Yeah, so actually right now it's disconnected. So please follow this recommendation, and we can proceed to rebar assembly. So actually I will do it very swiftly. I will just show you one layer of the reinforcement, and later on I will just open up the fully controlled model, because there is no necessary to spend some more time with the reinforcement procedure, because I do believe that's quite straightforward. So in the first stage, what you need to do, you need to assign the surface. So I wanted to have it on the surface number 1 or number 2, number 3, that should be labeled. Okay, so actually once you assign it to edge number 3, so here is some numbering of the edges, and actually the surface cover will be 30 millimeters, and the cover from the left will be also 35 millimeters. So once you have it, there is a number of the bars in a layer. It will be 4. The 4 bars in a layer after 180 millimeters or 170. And you can see I just already created the reinforcement 3 bars. I know that reinforcement 3 bars are ended up here as they are, but in the bottom they are penetrating or interfere this surface support. So you need to just assign the anchorage shape continuous bar. So it means that your reinforcement 3 bars is, you can imagine like that it's going through, but it's basically fixed to the area of the concrete here. Okay, and to the support. Yeah, it's basically catched or caught by the support, so it cannot be pulled out. Yeah. Okay, so this is the reinforcement. Let me to open up the finished model. Okay, so actually right now you can see calculated and reinforced concrete part. So in the region where the anchors are redistributed, they've been properly spaced or use the spacing in between the anchors, that the reinforcement are capturing the tensile forces mostly from the anchors. So in the first glance, you just go to the check and you will observe the stress flow, basically the compressive forces or compressive stresses. So once I increase the density of the stresses, you can see that thanks to the connections or the base plates are close to each other. So at this region, there is some coupling, and the region where those two, I would say, anchorings are somehow affected. So this is just the information that is coming from the stress distribution. If you want to do more, you're going to the strength, where you are able to double check what is happening with your reinforcement. The reinforcement is quite underutilized, so based on the reinforcement setup, I'm just exhibiting only 140 megapascals. So, the standard criteria for ultimate limit states are for B500, B435 megapascals. So I'm quite low still on the elasticity. So basically, if the detailing rules allow me to decrease the bars in the column, so I'm able to decrease the diameter of the bars to have it like a cost effective, I would say. But of course, I'm just investigating the anchoring, and there can be some like additional loads that are coming into the concrete column. So you have like two options. You can just assign the stress state that is coming from your global analysis and put it as a forces on the top of the column, and basically somehow activate the critical combinations and investigate if all reinforcement and concrete can survive this type of the combination. Or you can just leave it like that, analyze if your anchors and basically the anchoring will sustain the load, and you're just co-check it aside, maybe as a sum of the stresses, but that's basically up to you. If I will double check the anchors, so I'm just wondering that there is very low level of the stresses in the anchors. Once I go to the anchorage, so in the anchorage, if you go to the anchors, so there will be like a zero bond on the shank of the anchor, because all the forces are transmitting through the or via this plate. So actually there is like a zero bond stress, so that's working properly, and you are able to see also some displacement of the anchors itself and the forces, total forces. Perfect. I can just move to the auxiliary, where I'm just experiencing the mold shape that you can observe. It behaves according to my expectation, and I can proceed to the report, where I can generate a brief or so we can observe that the reinforcement, or sorry, the report has been generated. All the informations are imprinted, and you are able to just export it to PDF or docs file. So that's all from my side. Thank you for attention. I do believe that you enjoyed the session, and see you in the next sessions from IDEA StatiCa.